All right. I would ask if remote people can hear us, but none of them know what the URL is yet. So that's recording. And I will now do screen share. Share screen. All right. So do you have Python and stuff installed on your laptop, or have you been? Okay. So if stuff doesn't work, just we're gonna have to install something in Python. So if stuff doesn't work, either grab Daniel or just watch. Okay. You can go through it. I chose something that most people in the lab should have the installation environments for, but
okay. I'm pretty sure we had to download Python for the ILLO tutorial that I've been doing. So
okay, why was there an error loading? Okay. Okay, so right, I'm now over here, control this, and okay, but that's my screen, right?
Yes.
Yay! All right. All right, so Shireen is on and Amanda is on. That's a nice dog, Amanda. You're on mute.
Ah! I figured it out.
We can't hear you at the moment, though.
Yeah, I don't know how to fix
Amanda?
it. Hi.
No luck?
I'm trying to find the button.
All right. So you're all on Slack? Yeah? Okay.
Does that change anything?
GitHub repo.
Testing, testing. Can you hear me? Can you hear me?
I can hear
So you
you.
don't need to fork it or anything unless you really want to.
What is happening here?
They might have the TV, so maybe they don't have any speakers on.
Sounds like you can hear her.
I can hear her, yeah. So I muted the TV. You need to unmute your laptop or something.
But they're able to hear you.
They can hear me.
Yeah, we can.
I can hear you.
No, that's wrong.
Settings.
Okay, they can hear me.
Oh,
Oh,
I can hear you now.
I got it.
Can you hear us now?
Somebody can hear me. That's exciting.
Hi!
We can hear you.
We can hear you.
Okay, I'm back.
There's stern-looking ham. Right there. All right. And Harriet, where are you these days? And Tamer. Hey, Harriet. Where are you?
LA.
Okay.
I fly back tonight.
Okay. Okay. I think, is this the first time that our remote people have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 have equaled the number of in-person people? This is exciting. All right. Okay. So right. So let's get started, I guess. I don't think, is there anybody I should be waiting for? Phil is ill.
Camille?
Camille was up till 4:30 and is in town, so she said she'd show up. Plus, she wrote the tutorial that I learned how to do it from, so I'm going to go with, she doesn't need to be here, but her perspective would be useful later. Okay, cool. So in the teleconf channel of the Slack, there's a GitHub repo. And what you should all do, and I'll walk through it on my laptop in front of you, but what you should all do is create or enter one of your virtual environments and install the doit. Make sure you have both kchmr and doit installed. I think that's all you'll need. And then clone this repository. So I'll walk through doing that for those of you that don't have a lot of virtual env experience. I wonder if I should bother installing. I'll do a whole new virtual env. Oh, and you should use Python 3. I don't think I put in the Python 2 compatibility stuff. So I'm just going to do this in my temp directory. And this is always tricky because my laptop is still slightly screwy. But so I'm going to create a new virtual env by doing Python 3 -m virtual env, and I'll call it let's call it ILLO. And what this does, just to remind everybody, is it creates a shadow or a shadow or a child installation of Python in which I can install anything I want without installing it system-wide or with root privileges or anything.
I have a question.
Yeah.
I've recently been having some issues with Conda, and right now when I go to start a Conda environment, it says you should unset the Python path. That seems like a bad idea.
This is off topic for today's lab learning opportunity. I have no idea. I would talk. I think Luis is the local Conda expert, but I'm happy to. Okay. So I ran that Python 3 -m virtual env ILLO, and do you have to install? Are you having? Okay. And so I'm going to now activate the environment. And I'm going to install, and this puts me in this environment, and I'm going to do pip install, I think it's pydoit and khmer. And I can copy this. I don't actually know if it works, so wait a sec. It's either pydoit or doit. Yeah, it's doit, sorry. It's called pydoit, but you install doit. And while that's running, I'll just come over here, pip install doit. Okay, looks like I already have khmer installed. That's not a huge surprise. Oh, it's actually downloaded the wheel. How nice. Okay. And so now I'll wait a minute for everybody to finish up. But now basically we should be able to do import doit, and it should work. And we should be able to do import khmer, and that should work from within Python. Okay, and if you have trouble getting to this point, paste your error message into the teleconf window, and I'll see if I can recognize an obvious place to help. So you have to do pip install doit. Not. Fingers on wrong keys.
Okay.
All right. Whoa, what just happened?
Oh,
That's
I thought
pretty
I
cool.
was right. I thought I was trying to look for the Conda environments that I created, but I don't think I created one.
Okay.
Yeah.
Okay, so so I thought I'd give a little bit of background. I don't know how many of you have experience with makefiles. I don't know, Lisa, have you used makefiles much? Okay.
I've used them.
Yeah.
I've never made them.
So let's see. What's a good? Let's go to make lesson for software carpentry. So often when you're doing scientific analyses or you're writing papers, you end up with many different commands that you need to run in the right order. And by running in the right order, what I mean is you need to run a series of commands that produce intermediate files on the way to your final analysis. So you start. So imagine that this is from the software carpentry make lesson, and imagine that you have a script that counts words. Imagine that your scientific goal is to look at the word count distribution in books. So just stuff out of thin air, right? You have a bunch of books, and you want to calculate how many times what the distribution of word counts is. You know, how many times the, how many times is, how many times a, whatever shows up, and then you want the distribution of those abundances. And so you have a script word count.py that counts the words, and you have another script after that that takes the word counts and turns them into a distribution, and then you have another script after that that plots them or fits them or does something with it, right? It's a very, this is pretty much every computational workflow in existence. You either have some data that you're analyzing or you're running some simulations that produce some data that you're then analyzing. The important thing is each of these steps generally involves, or frequently involves shell commands. You're running stuff at the command line that takes some input, some set of input files, which we're going to call dependencies, and produces a bunch of output files, which we'll call targets. Right? So you can view, at some high level, you can view a computational workflow as turning, as specifying how to go from targets to dependencies and specifying the commands that need to be run for them. Now, a typical way of doing this that comes actually from software development is to use something called a makefile. And a makefile contains a bunch of lines like this, where you have the targets here, followed by a colon, or you have a target, followed by a colon, followed by a dependency, and then you have a tab. And after the tab, you have the command that specifies how to go from the dependency to the target. So here, the dependency is books/isles.txt, and to go from books/isles.txt to the target isles.dat, you would run Python wordCount.py, blah, blah, blah. Okay. So, so there's a couple advantages to this, and I'm not going to go through the advantages, but one thing is you're a little bit abstracted from just writing a shell script that says run this, then run this, then run this, then run this, which is nice. The most important reason it's nice is that when you have a makefile like this and you run it using a command called make will know that unless isles.txt is newer than isles.dat, it doesn't need to rerun this command. So you can specify what's called a directed acyclic graph, or a dependency chain, that tells you how to go from start to finish of an analysis, and it will only rerun, and as you're developing analysis, it will only rerun the bits that need to be rerun based on changing input data files. That makes sense. And then the third thing is sort of from a reproducibility perspective, at least in theory, makefiles and so on are easy to read, easy to run, easy to change. At the very least, they're easy to run. Whether or not they're easy to read or easy to change depends on who's writing them. So in this lab, we've been doing this for a lot of our scientific papers. We tend to write a makefile that takes the large data files and goes from the large data files to the smaller data files, like an assembly or a set of analyses in an assembly. And then we put the makefile in Git, and we post it as part of our publication. And that lets other people, at least in theory, go from our raw data to our results on their own computer. Right? So far, so good. Okay. The problem with that is that makefiles turn out to be really ugly in the large. That is, when you're actually doing a real data analysis, you end up with lots and 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 lots of stuff in your makefiles. So this is one makefile for a paper, for a preprint that we've posted. This makefile actually includes 1, 2, 3, 4, 5, 6, 7 other makefiles. And then each of those makefiles is likewise annoyingly complicated. And you end up with lots and lots and lots and lots of commands. So in particular, in this file, you may notice something, which is that there are a lot of commands like this that are basically identical and duplicated. It says, go from this file to this file by running this command. You can see this command is identical. It's just I replaced the 1 with a 2. Now, some people in the lab, like Luis, will know that there are ways to program makefiles. So you can actually say, like, OK, anytime you have a file name like this with a number in it, you can run this command and just replace the number. But as soon as you get into programming makefiles, now you're learning another programming language. And the makefiles become impossible to read for anybody that doesn't know that programming language, which is basically everybody. And it's just a disaster. Actually, Ali, who rotated in the lab last quarter, had to go through this makefile and extract some commands, and I gather it was rather painful. Right? So I wrote this. It took me, this paper took like 2 or 3 months of work to get all this stuff together, and I already knew what commands needed to be run. I just had to put them all together. And I find this completely incomprehensible. I mean, which is why I started looking for alternatives. Okay, so are there any questions or comments at this point? Everybody knows why we'd use a makefile. Everybody knows. Yeah. Remote folk, all good?
Yes.
Okay, well, so what I want to show you is something that I've started to use an alternative, and it's called doit, and it's sort of a recognition that if you're going to be programming stuff, which sort of is the inevitable conclusion of, oh, I'm writing a complex workflow, I need to program it, you might as well use the same language you're using for everything else, which in this case is Python. I resisted this for a long time, but I'll tell you, I'll show you the two examples that sort of pushed me over the edge. So first of all, I think I included this in the email out to everybody, but I learned how to use doit from Camille's tutorial, which I think we might have a recording of because it was offered remotely. What I'm going to do today is sort of walk through the things that convinced me rather than walking through the entire tutorial. The entire tutorial takes like 3 hours, and it's reasonably complicated, and we don't have time for it. So what I really want to do is sort of split the difference and show people that might just be interested in what this looks like, show them what it looks like, and then show people that have never seen any of this what it looks like so they can be motivated to do the tutorial if they're interested. And there's lots of arguments about workflow automation, save time rerunning analyses, save computational resources, self-documented workflow, reduce errors in your analysis, make you happier, and very, very important in this lab, make you smugly aware of how superior you are to everybody else in computational biology. That's certainly my motivation. There's also a lot of other useful things, and Camille doesn't actually put the most important thing in here because you wouldn't understand it until you got to the end of this, and that's make your life way easier, in theory. So okay, so what we're going to do is we're going to start with this Git repository, which I posted, and I'm going to post the command I used to clone it. So git clone that. And you want to be in your virtual environment or Conda environment. So you want to be in the situation. It doesn't have to be in the same directory, but you want to have that activated. And then you do git clone that. You'll end up with 3 directories and 1 file. And the directories are ex1, ex2, and ex3. And the file is simplegenomereads.fa.gz. So I'm going to start by showing you what's in ex1. Actually, let's just go into ex1 and type doit. You should get output that looks like this if you have kHmer installed. Good? Yeah. So what's going on? So I like running things rather than telling you what's going on first, because if they don't work, then we should stop and deal with that before talking more about it. So yeah, okay. So what ex1 does is it runs the command trim low abund. And it runs the command trim low abund, which is a kHmer command with the parameters -z20, -c3. It specifies some amount of memory and it specifies a kmer parameter. And it runs this command on this reads file with this much memory. Okay. So this is essentially the equivalent of that line that was in the makefile, which was to produce this target, run this command on this dependency. And all the other stuff is just sort of Python, like I'm defining the string, I'm formatting the string, whatever. Okay. Yes.
You might talk about this later, but so from a design perspective, do you recommend including all of your variables that you need for this one command within this function?
We'll get to it. We'll get to it. Yeah, that's exactly what example 2 is.
Okay, awesome. That's what I had.
Yep. All right. Are there any questions at this point on what this code kind of does, at least roughly speaking? Okay, it's also important to note there's nothing else in this directory but this one file, dodo.py, do.py. And when you run doit, what it does by default is it looks for do.py, it imports it, and it looks for functions whose name starts with task, and it runs them in order. Or sorry, it runs them, it collects the actions, the targets, the file dependency, and some other information about how frequently it should run it.
And the name of the function should start with task.
The name of the function should start with task. Yeah, I think later on that will relax that, but this is actually the way of using doit that I don't recommend. If you're going to do this, I would just use a makefile, because makefiles are simpler and are terser, frankly. Okay. So what it's running is it's literally just running this command on this file, and it's producing this target.
So that's the output that
It
will look
expects
for,
to
that
see.
it expects to see. And if it doesn't, then it'll run it again.
Right.
But if you run it and it does find that, then it'll just exit.
Right.
Okay.
So, well, let's see if that actually works. Okay, it doesn't work in this case. I must have screwed up somewhere, but it's pretty straight. The run once it should say, if this file exists, you don't need to run it again. I don't know why that was working like 5 minutes ago. So, okay. So, any questions at this point? I can talk about what trim_low_abund does, but 2/3 of the people in the lab are bored to death of k-chmur stuff. Basically, what it does is it error trims the short read sequences that are in simple genome reads.fa.gz. So, okay. Okay. So, right. So we have this one file, do.py. Oh, I know why it doesn't work. Because the target specifies .. And when you run the command, it actually puts the, so if you edit do.py and you change the target to be simple genome reads, and you run doit, it won't rerun the command. It will say, I've already done it. And if I remove simple genome reads.fa.gz and I run doit again, it'll regenerate it. So yeah. Okay.
So it just does like -- trim reads.
-- trim read says this is already done. And something that I don't particularly like about it is there's this file doit.db, and this is actually what retains the information about what's been run and so on. And so it's a lot more complicated than makefiles in terms of when it will and won't rerun. So you actually have to remove, if you want to force rerunning everything, you have to, or you can do a clean command, but that's a separate issue. You have to sort of flush this database.
And of course, it's binary.
It's a SQLite database.
Oh, okay.
All right. So here's where we are. We have this description of our task. The description of the task specifies its targets, specifies its dependencies, and specifies the command. All right, sorry? Any questions? All right. So this, as I said, is not that interesting. This is basically a makefile in Python land. That's nice, but I would use a makefile for this. Let's go take a look at example 2. So in example 2, let's try running it first. If you run doit in example 2, it works. It runs the same command, but the way the command is written is actually much more like something that Lisa just asked about. So here, we're defining this generic command, trim reads. Trim reads is a Python function that gives us a doit task to trim arbitrary sets of reads. And the way you specify which reads to trim is which read files to trim is you pass them in as a parameter to trim reads. And you can also pass in the memory. So this literally does exactly what the previous thing specified, but now it's parameterized. Now you can you can have multiple tasks that trim reads, and you don't have to redefine the whole thing every time. You just say, oh, I want to trim these reads, and I want to use this much memory to do it.
So if you had 600 files.
So if you had 600 files, you could programmatically generate the tasks to apply this command to each one of those 600 files.
And then specifying things like number of concurrent jobs to run are those options in doit, or
That I don't actually know anything about that. Camille is the expert on how to run these things in parallel and so on and so forth. I mean, she has the Dammit program does all of that, so she knows how to make that work. And my general philosophy is I would prefer not to have to run anything on more than one. If I have to leave my laptop to run something, I'm disappointed, basically. I'll go to an Amazon Web Services machine solely for the purposes of getting more memory. But if I have to run on more than one machine at a time, I get confused. So I realize that's not an option for some people, Lisa, but you know. But Camille has developed ways to say, yeah, run these tasks, distribute these tasks across a dozen machines, and whatever. Yeah. Cool. Okay. So this is super cool. This is actually already worth the price of admission for PyDoit, because now we could write as a lab, and Camille's actually already done a lot of this. We could write as a lab 20 different things that we do all the time: run Trinity, trim reads, do digital normalization, map reads, whatever. And we just write one library that we all use inside of doit, and because this is now importable. This can become from any of this can come from a library, from a module, and then our workflows would just consist of this. Right? Note that we don't have to explicitly specify targets or dependencies at this point. The targets and dependencies are figured out from what we're passing into trim reads. So Lisa could write tasks that say, take an SRA identifier, figure out whether or not the thing's been downloaded if it's not, trim it if it hasn't been trimmed, run Trinity on it, annotate it if it hasn't been annotated, right? And all of those tasks can be produced by one function call, which is like assemble this sucker, assemble this SRA thing, right? You'd have to use subtasks for that, and I don't know how to do that either, but you can. Okay. Because right now it's one function returns one task. Okay.
So you can run within one task. You can have tasks.
You can have tasks that are specified within that. Yeah. Okay. Or you can programmatically specify multiple tasks, basically. All right. Any questions at this point? No. Good. Yeah. All right. So let's go to example 3 and run. And here we're not going to run doit. We're going to run runme.py. If you run runme.py, it's going to say, wait a sec, this is not, the following arguments are required seek files. So we actually want to do runme.py / simple genome reads.fa.gz. No module named doit. So were you running the previous doit command?
Yeah, and they worked just.
Try doing Python space run the runme.py by running Python in front of it. /. Okay, so I don't know why that's not working.
Weird.
Is anybody else having problems with import errors for doit stuff? Okay. All right. So what's going on here? So this is essentially the application version of doit. It's going to look a lot more complicated. It's going to look a little bit more complicated, but basically, this is all magic that I think Camille basically came up with. What we do is we define this trim reads task, and this is now the same parameterized task that we had before. The only addition is that name is specified, And name is specified in such a way that it takes into account the parameters. So basically, this is the name of the task, and it takes into account the files that you're passing in and the memory parameter that you're using. Okay, so this is pretty much the same thing we had before. We've used this make task thing, which wraps it for PyDoit to know that it's a task. And then what I've actually done is I've written a script. And the script looks complicated, but the key bit is here. The script says, okay, let's define tasks. We're going to define the tasks as trimming the reads of args.seek files, which is passed in, which is the set of files passed in on the command line with the optional memory argument. And we're going to append that to the list of tasks, and then we're either going to run or clean, and I'll show you what these things do in a second. So, and then this stuff, for those of you that haven't seen it, is just the argparse stuff that lets you specify command line parameters. So when you run this runme.py, it says, it gives you this usage statement, and this usage statement comes from argparse. It's telling you you can specify the amount of memory, you can specify the -- clean flag, you can specify one or more seek files, and that tells you that seek files is required. So in some sense, this looks like we've taken a step backwards, right? At this point, we could just do trim low, right? If we're running runme.py, why aren't we just doing trim low abund in the first place, right? Why would we have this application that now we have to specify? It seems like a step backwards. We have to have this application that specifies what the input files are, and then it figures the rest out. So the advantage is that this is much simpler. Trim low abund, if you remember the actual command, that's something like this, whatever. And there's a lot of other potential things that you can put in. And so this is actually kind of annoying to have to remember to type all of those things in. And the point of a workflow is that it encapsulates all the parameters that you've chosen to run. So this is still kind of a workflow documentation tool. But really what it is it's a way to actually specify, it's a way to actually specify multiple tasks. You can have more than one task in here. So this is the sort of thing that Lisa could do if she wanted to have a script that said, assemble this SRA thing. She could have, download, trim, assemble, map, et cetera, et cetera, et cetera, all listed here. And I'll show you an example of that in a second. The other nice thing is if you run runme.py again and again and again, it doesn't actually run anything anymore because it's using doit, so it knows that the targets already exist because I ran runme.py before. So unlike trim low abund, which will happily run again and again and again every time you run it, here runme.py is running it only as many times as is needed, which in this case means once. So in essence, you've embedded the workflow engine in an application that will keep track of all the dependencies and targets for you when you're running it. Okay. Yeah, go
I
ahead.
have two questions. Can you explain the @make task?
Yeah. So it turns out that in order, the sort of short version is the really short version is I don't really know what it does. It is what's called a decorator in Python, which says apply the function make task to this function after the function's defined. And what it really does is it tells doit that task trim reads is a doit task. Because we're not running doit at the command line anymore, so it's not automatically going through the file and finding tasks. Start with task underscore and wrapping them and doing other things.
Mm-hmm.
We're defining the task and then we're passing it as a function in run tasks, as a function in a list to the run tasks command.
Okay. Does it always, because when you go down, like your run tasks now are not make task. Like what do you use for make task?
So here.
And then.
So what this does is it takes that function task trim reads, it parameterizes it with these seek files and so on, and then adds it to the list of tasks to run.
Okay.
So I'm doing it explicitly here.
So the name make task, is that always make task, or does that change?
This is always make task. This is actually
Okay.
something that Camille wrote.
Okay.
You can look at the code. If you want to look at the code, I'm not sure this will actually help you. But if you want to look at the code, what make task does is it wraps the task in something that ensures that the task has a unique function name, basically.
I see.
But a unique doit name. But I'm actually not sure this is required anymore. I've gone past this. But anyway, it's not as sensible. It's sort of how it's basically a way to tell doit that it's a way to encapsulate task trim reads and stuff that doit needs in order to run it. Okay.
My second question was so it's only checking for the presence of the file, not necessarily any of the content. What if you wanted to go into the file and check the content?
So you can, if you look at this up to date can take a function that will go and look at the files and verify.
Cool. Okay.
Yeah.
So up to date is
what checks to see whether or not the target is up to date with respect to the dependencies.
Okay.
What run once does is it says, oh, well, if the dependencies haven't changed, then I don't need to update the target.
But if you wanted
But you could change that.
to include the function within that list,
I think so.
Okay.
I have to question as to why you would want to do that, but
well,
we can talk about that later.
Yeah.
Okay. All right. So so now the funny thing is, let's see, is there anything else I wanted to say here? Okay. Okay, well, one other thing. So how do we force this to rerun, right? I could delete start out of unfilled, which is untrim, sorry. I could remove start out of untrim, and if I reran run me, it would run it again. But if I have a complex workflow, I may not be aware of what all the intermediary files are. Right, it may produce 100 different files, and I don't want to have to delete each and every one of them, make sure they're up to date, make sure they've been produced recently. So what you can do is you can actually do runme.py. You can give it the simple genome reads.fa.gz file, and you can say -- clean. What this will do is it will actually go through and remove all of the expected targets, so that next time you run this, it forces it to rerun everything. So why you might want to do this is that it turns out that when you're writing complex workflows, often you don't actually know at the end of the day whether the output of your workflow is actually the latest, whether it's been rerun all the way.
Yeah.
In make files, there's something called make clean, which attempts to do that, but you have to write that by hand. With PyDoit, since you're specifying the targets and you're specifying the dependencies, you can tell it to trash everything that it would have produced had it finished running. And now, when I run me again, it's actually guaranteed to reproduce everything that that it would have produced. It's guaranteed to rerun everything.
that might eliminate my need or my perceived need to write a function to check, to go into the files and check.
Maybe, depending on what your need was, yes. Yeah. So the nice thing here is because you're giving all the information to do it, it knows what it would have generated, and it can make sure that it's deleted things that should have been generated by your workflow and rerun them. So typically, for those of you that haven't written papers this way before, the last thing you do before submitting your paper is run a clean and then rerun everything. Because that way, you can say in the paper, like, I generated the figures and results in this paper from this version in GitHub using this command, and it's actually accurate. Obviously, if it takes a week to do that, you have to plan ahead, but that's typically what we recommend doing. Because usually you end up modifying scripts and figures and stuff a lot while you're writing papers. Okay. Are there any questions from the remote peanut gallery yet? Okay, one last thing that I'll just say. This is still annoying because we've gotten ourselves into this habit of we've gotten ourselves back into having to specify what we're running, of telling that we want to run runme.py on simple genome reads.fa.gz. And the whole point of workflow engines is that you want to avoid that. Like you want to avoid making the person running your workflow engine from having to specify anything at all other than where to run the damn thing. So, and I'm a little ashamed of this, and you don't have to follow along. What I actually do is I have a make file. And in the make file, what I do is I specify the commands that I would run. And now I can run make. This is annoying. My VI is not putting tabs in. Okay, so if I have this make file now, the make file runs runme.py on simple genome reads, and if I run it again, it figures out all of it figures out it doesn't need to rerun it again, and I can run make clean, it'll clean it up. I can run make. And this brings me back to my comfort zone of I have a make file that specifies which of the different doit tasks I want to run on which files. This is definitely absurd, but it actually ends up, for paper workflows, ends up being sort of nice. So let me show you how unless there are questions at this point, unless there are questions at this point, I can show you how I'm actually using this. Oh, I haven't heard this before. Where's the clock?
It's behind the TV.
I think we need to figure out how to secrete it in the other lab's room.
I agree with that.
You can also just unplug it and turn it off. Anyway, okay. So unless there are any questions, I'll show you how I'm actually using this in a real project. So, and not everybody, I don't think everybody has access to this project, so you'll just have to watch on the screen. But we have this project called Spacecraft Cats, and the paper repository is called Cats in Practice. And we have a pipeline. And the pipeline is an analysis pipeline that runs a bunch of commands. So this is my make file. And it looks annoying, and it is annoying, but it would be way more annoying if it were actually specifying all of the commands if it were specifying the tasks in the make file. So let me just walk through what I'm doing here. So in the make file, I say, okay, I want to make this target acidosim catless, and acidosim catless is makes a simulated data set called acidochunk reads from these two input files, and then it runs a couple commands to go in and extract reads and so on and so forth. Don't really worry too much about what this is doing. The key point is both make sim catless and recover reads are our doit shell script, our doit Python scripts. And if you look in here at make sim catless, you'll see this looks remarkably like what we just did, which is I have an arg parse. I say, okay, I have a command line parser. I say, here are the input FASTAs. Here's the directory name that I want the output to be. Here are the read files. Here are the input read files. Here are the output files. And then I define a bunch of tasks. And these tasks this task definition does a couple interesting things. Basically, for each of the input FASTA files, it makes a bunch of simulated reads using a doit task. And it does this. So this is where someone like Lisa could say, I know I'm going to have multiple output files. For each of those output files, build a new task specifically for each one of those output files. This is very hard to do or annoyingly difficult to do in a make file. Then I have the task trim reads, and what task trim reads does is it runs that same command we've been using before. It actually just copied that command from here, and it runs it on all the read files, and then it runs the next couple steps. So what this script is actually doing is running 4 different things. It's making simulated reads from some input data. It's error trimming those reads. It's building a compact de Bruijn graph, and it's building this thing that we call a catless. And those tasks are all specified here in this script. And it does so using the doit stuff, the doit library, so we can both run it and we can run the clean command to reset the whole thing. So it's another layer of abstraction that lets me manage all of the workflow involved in creating this simulated data set, which involves multiple steps. I have a bunch of different things in here that I have a bunch of different scripts in here that make use of this. So you might think, so what I'm starting to use this for is I'm actually thinking that in the future, when we write applications, when we write new programming scripts that we want other people to use, we'll write them as doit scripts. So we'll say, okay, you want to trim your reads? Great, trim your reads. Or you want to run a Trinity assembly using digital normalization? Great. Here's something that will take your reads, trim them, digitally normalize them, and run Trinity on them, and it will restart when it fails due to out of memory or out of time or whatever automatically because we've written it inside this doit workflow script. Right now, if we wanted to do that in our KHMR scripts, it would be a massive pain in the butt to coordinate executing multiple commands on the same set of data files. This makes it actually remarkably easy. And if you look at these scripts, it's sort of the closest to perfect that I can imagine, because basically you're saying, okay, all I'm going to do is I'm going to specify the input arguments, and then I'm going to write the tasks down, and then I'm going to say run the tasks. And there's no like, oh, check to see if the files have already been created or if they're like in a state of disarray or whatever. doit takes care of all of that underlying looking at the files and figuring out which tasks need to be run and coordinating the running of the tasks. If you combine this with the stuff that Camille's doing, where you can distribute these tasks across multiple processors and multiple nodes, then all of a sudden you now have parallelization for free, right? You say, oh yeah, I want to trim these 15 different files, and you just have a parameter that says, well, how many nodes do you want to run that on? And then let doit figure out how to distribute them among the nodes and wait for the results to come back and so on. So all that stuff in theory comes more or less for free with doit. So let's see, I had a couple other. The downside for all of this is that, let me just make sure I list all of the things. Okay. The downside to all of this is that this is basically incomprehensible to anybody that wants to figure out what's actually being run. So you know, if you're trying to, with make files the way I wrote them, you could at least in theory, well, in practice, nobody can understand what's being run in this make file either. But I used to hold out hope that we could write papers that were like fairly simple, like take these reads and assemble them and then analyze the assembly this way and then analyze the assembly this way, and that would be our paper. But every one of these layers that we add on is like another layer standing between the reader and figuring out what actually was executed. So I guess I'm mostly interested in getting to the point where the make file, I mean, this is a skill, this is a learned skill rather than something that I know how to do already, or this is soon to be a learned skill, hopefully. You know, this is going to be the make file for the publication, which is like, okay, for figure 1, you go down and you look, okay, figure 1 is build this simulated data set, run these commands, and then plot figure 1, right? And then people can go dig into what plot figure 1 actually does. They can dig into what, you know, and so it's another layer on top, but maybe it's a layer that you can make sort of simple looking enough that people will know where to go when they need to dig in more. On the flip side, when you look at the advantages for the lab are really pretty amazingly cool. If you look at this pipeline, which you can't do, but the idea ultimately is that we might have this list of tasks, right? So here I have a task that makes simulated reads. And all you need to do is give it the input file name, and it will run the make reads command that makes simulated reads, and it will specify the targets and the dependencies and so on and so forth. If I want to use this in a script, I can just make me some simulated reads in from this genome or transcriptome or whatever, and then this command will do the right thing. And then I can chain it with trim the reads, and then I can chain it with build a compact De Bruijn graph, and I can chain it with other things in here. And so then once we've written all of these tasks, this now becomes a library that you install with the pip install command, and you just use in your application, you use in your workflow. So it's got the advantages of that extra layer of abstraction that we're wrapping these predefined tasks up in a nice way that Lisa can just reuse them whenever she wants to, but it's got the disadvantage that this is one more layer of abstraction. So anyway, I don't know. Any comments or questions at this point?
So you were talking that this can help you if the job failed or whatever, the command failed in the middle, that you can resume this from where it stopped and continue, right?
Right.
So does it feel the corrupted files? Like if I'm running a command and the command give me an incomplete file, I don't think this can feel this.
So as long as the command, so it's a really good question. As long as the command exits, well, there's two ways to deal with it. You could do one of two things. You could either make sure that the command that gives you a corrupted file exits with a non-zero status, right? If it exits with an error status, like any Unix command line utility, then PyDual will know that and will rerun it. Make will actually delete the output file if the command exits with a non-zero status. So that's how make deals with it. So that should just work. The other thing you can do, and I don't know exactly how to do this, I would have to experiment a little bit, but you could have a follow-on command that verifies, right? As part of the task, you could have a command that verifies the validity of the output file, and then deletes it if it's not valid. And that would be a way of making sure that the output was valid. From a computer science or from a computational scientist perspective, I would wonder why you have commands that are producing invalid output files, but I know that this is not a perfect world. So
you're asking how this is happening? I mean, this is happening all the time.
Why? Lisa's like, it just happens. It just happens. Okay.
I mean, like in my case, for example, those IO output errors, it just stop in the middle.
Okay. Well, but then
sometimes traumatic, and this has happened to me a couple of times. It exit perfectly, and you discover that your file is incomplete.
Yeah. Okay. So so in the second command, which was actually what I was guessing you were talking about, the second situation where Traumatic says everything's worked fine, but it hasn't, then you'd have to check the validity of the file. You'd have to have something that would probably open the file, seek to the end, and see if it's a valid ASCII file. In the first case where it's an IO error, if there's an IO error that kills the program that's running, then doit would know that and would fail to record that the program exited properly and would rerun. So unlike make, I mean, this is an advantage of doit in some sense. Unlike make, it tracks whether or not a command exited successfully. Make will just, if you killed something that had progressive output in the middle of a make file when it was running, make would only know that the file that existed that was more recent than its dependencies, and it would be fine with that. Whereas doit would not record that command had executed successfully, and would then rerun it because of that doit.db file. So it should handle your first case, Tamer.
This is good.
So.
And sometimes if you don't specify enough time in your job will just.
Your job will just get axed, right?
Right, but you'll have output. It just won't be complete.
Right, and so this is built for the situation where your commands are small enough that some of them will have been completed, but not all of them by the time your job gets the axe.
But then it won't go on to the next step because your input will be incomplete. So can you just do a make or like a doit clean or clean doit and then start over again?
Actually, I think what you could do, right, is you'd resubmit the thing that got killed.
Yeah.
And as long as you're using doit to manage all the tasks in there, it would not rerun the tasks, the subtasks that had completed in your shell script, and it would just run the ones that hadn't completed. So it's actually perfect for what you're.
So you wouldn't have to go all the way back to the beginning.
Yeah.
You could just.
So if you were evil, and I'm not saying that in this lab we abuse high performance compute clusters or anything, but if you were evil, you could put together something that's going to take some arbitrary amount of time, but that has a lot of granular steps in it, right? Like download the SRA file, trim it, digitally normalize it, whatever, run Trinity on it, or run the steps of Trinity on it. However, I think you can break the Trinity steps down a little bit. It would run all of those inside of doit. And you could just say, run this for 4 hours. And it would do as many of them as it could. And then you just resubmit it, run this again, and it would instantly go through the bits that it had already completed, and it would start where it had left off. What you'd be losing.
Assuming that you can find the files.
That's you know, this is
like
this is your set of problems,
issue,
yeah. But it would the disadvantage is you would lose everything between the start of the last command to run and the kill. So if you had a bunch of 5-minute commands, you'd be losing at most 4 minutes. If you had a bunch of hour-long commands, you'd be losing a quarter of your commands. So something to think about. But this is the way Trinity should have been written, I think, something like this. This is what Trinity kind of tries to do, but it doesn't do so well. Sorry, Tamer?
Yeah, so I think I discussed this problem once with Louise when we were talking about make, that those kind of schedulers has a problem with submitting jobs to the HPC, because now the command actually is coming back that the command is done, but no output is generated. You see what I'm saying? When you queue sub something, the command is executed, but no output is generated immediately.
Right. So what you would do is you would write a shell script that called, you would write your Q subscript that called doit. So you wouldn't call the Q sub from within doit. You would instead use the Q subscript to run your doit commands.
Oh yeah, I see.
Okay. Yeah. Okay. So one other thing just before you run off and people run off and rewrite everything they're doing and doit. Please don't. You know, if you have something that's mostly working, keep it mostly working. If on the other hand, like Lisa, you've got something that is mostly working, but that you expect to run another dozen times, and you keep on running the same problems, there might be selected parts of that that could be rewritten like this. Okay. Right. So like I wouldn't suggest that Shireen rewrite her thing and do it unless she wants to on the side. But Tamer, who's now running essentially the same GATK set of commands on 8 different data sets or 100 different data sets, right, Tamer? You know, Tamer that might actually be a useful investment of time and energy for Tamer.
I was planning to use by doit, but just think in finalizing what I have with make, then I can change it later.
Well, so you could start simultaneously rewriting it and do it, right? I'm just saying don't throw away the stuff that's working in favor of the latest shiny.
Okay.
Please. we have other people in the lab that specialize in doing that. Okay. So unless people want to talk more about doit, I have one more cool thing to show you. Luis hasn't given lab meeting yet, right?
Recently.
Recently? Okay. So are people ready? Are done with doit? Yeah? Okay. I'm going to turn off recording. Just a second.